Hello again there and welcome to Chemcrackers, and today we are looking at calculation of enthalpy changes of reaction from enthalpy changes of formation. Now we are going to be doing this by applying Hess's law. Alright, so first we need to understand the relationship between enthalpy change of formation and enthalpy changes for a reaction. Now, for a reaction, you basically turn reactants into products. All right, and the link with formation reaction is that the elements that are required to form the reactants are the same elements required to form the products. Okay, and what we've created here is a cycle, and if we put in the energy terms, then we effectively have an enthalpy cycle. So if we label the enthalpy changes involved, then this will be delta H of reaction. All right, and this, converting the elements to the reactants, will basically be the enthalpy changes of formation for the reactants. Okay, and of course on the other side will be the enthalpy changes of formation for the products. I'm just going to add PROD for products. So we can derive the Hess law relationship from these enthalpy changes of reaction. The relationship here shows that delta H of reaction is equal to the negative of the delta H of formation of the reactants plus delta H of formation of the products. Now, what we are going to do is to apply this principle to calculating the enthalpy change of reaction for this reaction that we're looking at. So we're going to be doing a specific example. So if we look at this reaction, we are reacting ammonia and oxygen to give nitrogen monoxide and water. Okay, so if we rewrite the equation, so this is our reaction. 4NH3 plus 5O2 gives us 4NO plus 6H2O. Okay, and we can form these reactants from the elements, and we can form these products from the same elements. And the elements required are nitrogen, which is N2 gas at room temperature and pressure. Oxygen gas is O2 gas. And we also need hydrogen gas. And the amounts that we need 5O2, we need 4N, so that's 2N2, and we need 12 hydrogen, so that's 6H2 and gas. Now we can label the enthalpy changes and then derive our Hess's law relationship. Now, to label our enthalpy changes. So this is the enthalpy change of reaction that we are trying to determine for this reaction here. Here we're forming ammonia. So this is delta HF of ammonia. But we're forming 4 moles of ammonia. So this should be 4 times delta HF of ammonia. Here we're forming oxygen from oxygen. So we're forming an element from itself under the same conditions. That's not a change. That's the same thing. So delta HF here, by definition, is 0. and we know that delta HF of any element is 0, and it would be times 5, but it's going to be 0 anyway, right? 5 times delta HF, which is going to be 0. Here we are forming 4 moles of nitrogen monoxide, so this is 4 times delta HF of NO. And here we're forming 6 moles of water, so this is 6 times delta HF of water. We can now write the Hess law relationship for these energy terms in this enthalpy cycle. Delta HR theta is equal to 4 times delta HF of ammonia, because we're coming in the opposite direction. That's minus that. So we have the negative plus this move, which involves 4 times delta HF of NO plus 6 times delta HF of water. And we can now simply fit in the values and calculate our final answer. So if you fill in those values, delta HF of NH3 is minus 46, delta HF of NO is 90, delta HF of water is minus 286, then your final answer will be negative 1172 kilojoules. Thank you for watching. See you next time on Chemcracker.